First, I'd like to give a little background about how I came across the Variac, and then I'll talk about some of the things that are wrong with it and what I'm going to do with it. A friend of mine from college informed me that a local engineering industry leader was going to be having some auctions of their old equipment. My parents actually used to work at this very same building, and when I mentioned the auction to them, they were as excited as I was because these opportunities are rare and often slip by unnoticed. Coincidentally, my mom was in town, and she decided to help me bid on a couple things and go pick them up since I had just graduated and started to acquire the equipment that I would need to continue learning outside of school. You may have noticed from some of the previous pictures that the Variac inside the box is actually a General Radio Type W10 Variac. I believe the Variac itself was purchased by the engineering facility, and then they actually just put together everything else and assembled it in this metal box. Upon closer inspection, I believe that the original engineer who wired this made a dangerous decision. The load side is wired with a common hot, where neutral is on the wiper instead of a common neutral, and this makes it so that the AC voltage between neutral and earth ground can be up to 120 volts, where normally it's around 0 volts. In addition to fixing the dangerous wiring, you can also see the hole that I drilled into the front of the faceplate. The Variac currently doesn't have any on light, so I'm going to use this LED, which has a resistor and a 1N4007 1A rectifier diode, so that I can have some sort of an on light when it turns on. Speaking of turning on, when the Variac is first plugged in and the coil energizes, you can hear the humming from the 60 Hz and 120 Hz, whatever harmonics. And one of the hopes is that after I redo the wiring, this hum will be eliminated, even though it doesn't bother me much. How about we listen to that hum now? I did FFT processing on the WAV file that had the hum sound recorded in it, and I got the resultant graph. Here you can see the 60 Hz, 120 Hz, 180 Hz, all the way up to the nth harmonic of 60 Hz, and a little bit of noise also in the graph. I start by measuring the AC voltage across the neutral, which is the Variac wiper, and the common hot on the load side. And for most of these measurements, you're going to need to wait until I get a stable connection with the leads. It reads about 0 volts AC because the Variac knob is all the way counterclockwise, which is set to 0 for the output. As I turn the knob clockwise, you can see the AC voltage starts to climb from 0 up to 120 volts. You should ignore any of those jumps that you see from probably bad probe connection. And then after it gets up to 120 volts, which is the normal outlet voltage, I can get it to go a little bit past that, up to 140 volts with the extra turns of the coil. Now I'm changing to measure the AC voltage across the neutral, which is still the Variac wiper, and earth ground. And normally this measurement comes up as about 0 volts on a normal wall outlet. You can see that the neutral prong, which is connected to the wiper, is actually 120 volts with respect to earth ground. And that's what the Variac knob set to 0. As I turn the knob clockwise, the AC voltage to ground starts to drop from 120 down to 0 volts once the wiper actually hits the real line neutral wire. Then it goes up to 20 volts once the wiper goes across the extra turns. You can see right now I'm trying to balance it so that it's at 0 volts, so that the wiper is at the actual neutral wire. And then now I have it cranked so that it's 20 volts because the wiper's across the extra turns. Here we can observe that the hot output on the load side does not change potential with respect to ground. It stays 120 volts at every knob position because the wiper is not connected to the hot in this case. This was wired wrong. This is the second iteration of the schematic after making some errors in my first one because I couldn't read the plate very well that the wires were connected to. I also show some of the current flows and some of the notation for the coil turns and voltages for the Variac. I'm pretty certain that this drawing now takes all the parts of the Variac into account and is accurate to the physical representation that I have sitting with me. Here you can see on the left side we have the 120 volts plug that goes into the wall, comes in with the hot wire on top and the neutral wire coming down the left side of the picture. The right side of the picture has the two outlets that are on the front of the Variac that are the outputs for the load. It's clear from the picture that the right side of the outlet prongs are tied in common with the incoming hot line, which is located at the end of the coil, and the left side of the output prongs are connected together, and those are going to the Variac's wiper, which is currently positioned somewhere in the middle of the coils. Normally, I believe the roles of this are reversed so that we have a common neutral coming in that also goes to the output prongs instead of the hot that comes in as the common. Also seen in the diagram, on the right we have an AC voltmeter, an AC ammeter, a current shunt for measuring higher currents than the original meter could actually display, and then on the left we have a fuse and a neon indicator light. The neon indicator light stays off when the fuse is intact, but if the fuse blows, current is directed through the large 336 kiloohm resistor and the neon indicator light turns on, showing that the fuse has been blown. This indicator light is off during normal Variac operation, which is why I want to put the LED just so I know when this thing gets plugged in. Now I'm going to cover some of the measurements that I took earlier just to see if they match with what the diagram says should be going on. So I started measuring the AC voltage across neutral, which was the Variac wiper that's shown in the middle of the picture, and hot on the load side, which is shown at the top of the image. This measured about 0 volts AC because the Variac knob was set all the way to 0, and that means that the wiper was positioned all the way up at the top so that it was touching the hot line on the top. This means that the Variac wiper was at the same potential, which is why we expect 0 volts. As I turn the knob clockwise, the wiper starts to move down the page and the AC voltage starts to climb from 0 up to 120 volts. It reaches 120 volts once the wiper hits the actual supply neutral near the bottom of the image. The voltage then continues to go all the way up to 140 as the wiper sweeps across those extra auto transformer coil turns at the bottom of the page. The measurements that were just discussed were probably taken by the original engineer who wired this, but they probably didn't go the next step to actually measure the AC voltage across the neutral, which is the Variac wiper in this case, and the earth ground on the load side. Normally this is really close to 0 volts AC on a normal wall outlet, but as we can show, we can actually get this to change all the way up to 120 volts maximum. With the Variac knob set to 0, the wiper that's shown in the middle of the page is actually moved all the way up to the top so that it's touching the hot line and is at the same potential as hot. This makes sense then why the voltage from neutral to ground would measure 120 volts then, because the neutral is actually on the wiper and it's touching the hot line. As I turn the knob clockwise for the Variac, the wiper starts to move from the top of the page down towards the middle, and the AC voltage to ground in the wiper goes from 120 volts down to 0 volts. It reaches 0 volts once the wiper hits the actual line neutral wire that's coming in from the wall. Once I continue to turn it a little bit past that, the voltage then will travel back up to 20 volts once the wiper sweeps across those extra turns at the bottom. To fix this wiring, I'm planning on switching the incoming hot and neutral wires from the line, and also switching the outlet points so that the common terminal is connected to the neutral and the wiper is not on the neutral anymore. We want the wiper to be on the hot part of the load outlet.